Given any right-angled triangle, we are always going to have the longest side called the hypotenuse, which is always opposite the 90-degree angle. Now, we also have two interior angles. I have called them theta and alpha. Focusing on angle theta is our reference, and I'm going to give you an exercise to do using angle alpha and seeing that we would arrive at the same conclusion. So the orientation of the right angle triangle is not important. The only important thing is that it's actually a right angle triangle. Now, given angle theta over here, this side here is called the opposite side. So it's the opposite side to angle theta. This is the opposite side. And the third side over here, which is not the opposite nor the hypotenuse, is called the adjacent side. We are going to use these sides to define the trigonometric ratios. So for example, if you were to use alpha, this would be the opposite. But since I'm using theta, this is my opposite. Now, sine of theta, sine of the angle theta, as in the diagram, is defined as the ratio of the opposite side over the hypotenuse. And also cos theta is defined as the adjacent side divided by the hypotenuse. So taking cos of the angle theta is the same as taking this ratio over here, and then taking the sine of angle theta is also the same as taking the opposite and dividing by the hypotenuse. So this is the important definition that we have first. That we have defined sine theta as opposite of a hypotenuse and cos theta as adjacent of a hypotenuse, we are going to find our first identity. And that is that the identity of tangent theta is the same as sine theta divided by cos theta. So the definition for tangent theta is the ratio of sine theta over the ratio of cos theta. So let's see what this actually tells us, because it's also going to lead us to a new ratio. So tangent theta is equals to tangent theta is equals to sine theta over cosine theta, but that means that it's equal to the opposite side divided by the hypotenuse, which is going to be divided by the adjacent side divided by the hypotenuse. Now, as I had mentioned in the introductory video, it is important for us to know how to deal with this one. This would mean that we can take the opposite side divided by the hypotenuse and then multiply it by the reciprocal of this one, which is hypotenuse divided by adjacent side. Therefore, these two would definitely cancel out, so we would have the opposite side divided by the adjacent side. So this is a new ratio. We can define also tangent theta for theta as defined before is also equal to the opposite side divided by the adjacent side. So we have a very nice acronym, SOHCAHTOA, to remember these kinds of ratios, and that is sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equals to opposite over adjacent. So okay, now before seeing the next identity, I would like you to take some time to pause the video and do the following exercise. Take sine of 15 squared plus cos of 15 squared and see what it gives you. And then sine of 402 squared plus cos of 402 squared and see what it gives you. You can also do for various numbers here, just making sure that they are the same in both cases. If you have done the exercise, you ought to have realized that you are getting one each time. Now let's look at this in terms of our ratios. Sine squared theta plus cos squared theta is equal to opposite side over hypotenuse by our definitions squared plus adjacent side over hypotenuse squared. Now this here gives us, by laws of exponents, opposite side squared divided by hyp squared plus adjacent side squared divided by hypotenuse squared, which by fraction addition is going to give us opposite side squared plus adjacent side squared divided by the hypotenuse squared. Now, if you recall our triangle, it was of this format here. We had a triangle like that. We had our right angle there, and theta was over here, such that this is the opposite side and this is the adjacent side. And then the longer side was the hypotenuse. But by Pythagoras' theorem, the addition of the square of these two sides should always give us the square of the hypotenuse. Therefore, we can conclude that this here boils down to the following. This should be also equal to hypotenuse squared divided by hypotenuse squared, since opposite side squared plus adjacent side squared equals to hypotenuse. Then this definitely gives us 1 for all theta. So for all thetas that we can. Okay, at this point it is very important for me to note down that for you who use various materials to study, especially the outdated materials, you might come across trigonometric ratios such as cosec theta, sec theta, and cot theta. Don't be shocked. They are not included in the CAPS material because they are not essential to our mathematics. We can actually use sine theta and cosine theta to represent these ratios. Let me give you a quick example. Cot of theta is defined as 1 over tangent theta. But this is nothing but 1 over sine theta divided by cosine theta by the definition of tangent, which is actually equal to cos of theta divided by sine of theta. So therefore, we can represent each and every one of those ones as sine theta and cosine theta, or ratios of sine theta and cosine theta. So don't worry about them at all.